Welcome to our first exercise on measurement and error. This is your first lab for this course, and it's an important one. It sets the stage. We really want you to understand the difference between precision and accuracy, and how to find precision and how to find accuracy for a particular exercise. So again, this is only the freshman level, but we will try and give you the building blocks to help you progress. One of the most important things to know about any experiment is the precision. That means, to what degree are you sure of your measurement? How many decimal points can you go out? This is a pan balance, which we're going to start out with. It is precise to within 0.1 grams. This is a digital balance. It's 10 times more precise. It reads off to 0.01 grams. That means, if you mass something, it'll go like 51.20, where this one would be 52.0. This is a digital balance that's the same as our pan balance. It's accurate to precise to within 0.1 grams. Here we have a mechanical balance that's an analytical balance. That means it's really, really, really precise. Fractions of grams, like a fraction of a milligram, it'll go down to. It's very, very precise. It's very hard to learn to use it though. And nowadays we have digital equivalents of it, but these were made in the 1800s and they were just as good as the digital equivalents, and they don't need electricity to run. But again, they need to be maintained. So what we're going to do is first start off learning about how this pan balance works. Every balance that you see that I've showed you works on gravity. They actually, what you do is you put something on something, gravity pulls it down, and it pushes down on something until that something pushes back with an equal and opposite force. So for the particular pan balance, it's a torque balance. There's a little knife edge. If you push down on here, the knife edge is right in here. It pushes up to the other end of the pan balance. So right now it's not balanced, so it's because I have these things. I got to put everything into zero. And when all of these weights on the right-hand side are zero, it should balance. And there's actually a 0 point over here. And it's very close to zero. Pretty close. So what we're going to do, start out to practice using these things, is use two elements, iron and aluminum. Now these are a part of what's called a mole set. Both of these have the same number of atoms in them. This steel rectangle specimen, that has exactly the same number of atoms as this aluminum one. But each atom in the iron is heavier because it has more protons and thus more neutrons. So for each atom is heavier, it's not going to occupy as much space as the aluminum to get to the same mass. So you need less atoms for a single cubic centimeter to get to 1 gram than you would for something with less stuff in the nucleus. So again, these are called mole sets. Each one of them has exactly 1 mole of atoms in each of them. And so when we mass them, it should have the mass of 1 mole. So I'm going to put the aluminum up first. And I already looked to see if it's zeroed off. So what I first want to do when you actually measure everything is move the heavier weight. Do you see how the heavy weight makes the whole thing go down? So that's not going to work. It's less than 100 grams. Now the 10 gram one is up here, so I'm going to keep moving it up. Okay, until it moves down. Okay. So once it hit 30 grams, notice how the right-hand side moved downward. That means that the mass is less than 30 grams. So I'm going to go back up, put it in the 20 slot. And then I'm going to use this one right here. Now you can see it's focused a little bit better. I'm just going to move this up until it balances. So let's see. And I need to push it a little bit higher. So we're going to do this 3 times. And that looks about right. And then measure it off. So there's 20 grams here, and then there's 27 grams, 0.1, and it's in between 1 and 2. So I would say my first measurement is 27.15 grams. So even though this particular device only is precise doing plus or minus 0.1 grams, sometimes the skill of the person looking at it, you can get like halfway in between. So that's my first measurement. Then what we're gonna do is move everything to 0 and re-zero it. So I take the aluminum bar off, and I'm gonna re-zero it to make sure. Okay, so now it looks like, do I have everything? It looks like it's a little above 0. Okay, so I'm gonna move a little adjusting pin here inward. So this is a tiny little weight, and it'll either move further or closer to the axis of rotation, meaning it'll give a little bit more torque. That looks better. It's maybe a little bit too much. Let me just. All right, that's a little bit further out. It's just not quite on there, almost. And it takes a while for it to stop swinging. So now we're going to take our second measurement. I'm going to put the aluminum back on here. Put this, I already know it's 27 grams, so it's on 10. I'm going to put it on 20. There we go. Okay, so now it's on 20. And I will now move up and take my last measurement. So let's see if I can see both at the same time. All right, so it's a little bit below still. A little bit less. Every time I move it, it takes a little bit of time for it to balance. Okay, that looks pretty good. So this was 27, it's 26.95. 26.95. So I'd say my second measurement is 26.95 grams. And again, I take the aluminum cylinder off. I re-zero it. Because remember, it really depends on the particular skill. Sometimes if I may accidentally move this around, it's supposed to be level. Now it looks like it's a little below it again. So let me just see if I can adjust it. It's getting a little better. I need to pull it out a little bit more. All right. That looks pretty good. So the little silver guy goes back on. And let's go see it balance again. Oh, that was actually, it's pretty close. It may be a tad, it's a little tiny bit under, so I'm going to move it slightly that way. All right, so our third measurement for aluminum is 27.1, okay, so a little over 1. So I'd say it's 27.13, 27.13 grams. So there's your 3 measurements. Average them out, find the standard deviation, and we'll go on to the next cylinder, it's not a cylinder, rectangle.